Hey guys, Mr. G here. In this video, we're going to take a look at graph transformations for trig functions. In the previous video, we took a look at examples with the change of amplitude and period. In this video, we're still going to look at those two things, but we're also going to look at two new things for the transformations. All right? So we have this function. We have y equals to a times sine of bx minus c plus d. So we're already familiar with a and b, but now we have c and d as the new addition to the graph transformations. All right? So we have a, an absolute value of a is the amplitude, which is the height of the graph. B, which is the period, and to figure out the period of a graph, we take 2 pi or 360 and divide one of those two by b. And then this is where we have our new transformation. We have C, which represents the phase shift. Now this phrase may be new to you guys, but it follows the same rule as horizontal shift. All right, so for the phase shift, we have a formula, which is C divided by B. C for whatever number, in this case radians, is on the same spot as C, and the coefficient for x. All right, so even though we have a formula for phase shift, we still follow the same rule for a horizontal shift, which we follow the opposite sign. So since the horizontal shift, we're moving from left to right, we follow the opposite sign. So if we were given a minus, the opposite of that is plus, and the right side is a positive direction, and vice versa for the left side. All right, and then we have a vertical shift. Nothing new. Vertical shift is still the same thing as any other graph transformations for any function. We follow the same sign. It's going either up or down. But with the vertical shift, it does help us figure out the midline for any trig function, and it helps us figure out the max line and the min line. So what I mean by max line, I mean all of the points that are maximum points that fall in this line, and same thing for minimum, all the minimum points that fall in this line. So we take my number that is d, and I add it and subtract it to figure out my to the number for a. All right, and then if you guys recall, we have the x and y table for the parent functions for sine of x and cosine of x. All right, so let's go ahead and get started with some of these examples. So we have number 1, which is cosine of x plus pi over 2. All right, so if we take a look over here, we see we just have a pi over 2 as our only transformation. All right, so with that, we see that the pi over 2 is in the same spot as c, and c is being used to figure out the phase shift. So let's go ahead and figure out what the phase shift is for this function. All right, so with the phase shift, I take pi over 2, and then I divide it by my coefficient in front of x, which would be b. And since there is no number for b, since there is no number in front of x, my coefficient would just be 1. So I would divide this by 1, and any number divided by 1 is the number itself, so this stays as pi over 2. All right, but before we graph the function for this, let's go ahead and find our information for this graph, which by finding the period, the amplitude, and the midline. So for the period, I take 2 pi, and then I divide by the coefficient for x, which is still 1. So 2 pi divided by 1 is still 2 pi. All right, and then we have the amplitude. So with the amplitude, it's usually the amplitude would be the number that's in front of the trig function, and there is no number in front of cosine, so the coefficient will be 1. So the amplitude for this function would be 1 unit. And then for the midline, usually the number we use for the midline would be added or subtracted to the whole trig function. And there is no number that's being added or subtracted to it. So that means that my midline is going to be at 0. So the midline is y equals to 0. All right. So we have our 4 pieces of information to graph cosine of x plus 2. Now we only have one kind of shift happening, which is the phase shift or the horizontal shift. So we have plus pi over 2 or 90 degrees. All right. So the phase shift follows the same rule as the horizontal shift. So we follow the opposite sign. We're given a plus, and the opposite of plus is a minus. And with that, that's going to be the left direction. So I'm going to move each point to the left by pi over 2 or 90 degrees. So let's start with this point. So if I were to move this point pi over 2 to the left, it's going to go out of the graph. So I'm not going to start with this point, but I'm going to start with this one. So I have pi over 2, and if I move it pi over 2 to the left, I'm going to end up at 0. I'm going to end up at 0, 0. All right. And then I have this point, which is pi, negative 1. So I move it pi over 2 to the left. I'm at pi over 2, negative 1. And then I have 3 pi over 2, 0. So I'm going to move it pi over 2 to the left. I'm at pi, 0. And then I have over here pi, 2. And I move it pi over 2 to the left. I'm at 3 pi over 2. All right. And then I connect whatever points I have left over. So if we take a look, we see the graph shifted to the left. All right. So we really didn't need an x and y table for this one since we only had one kind of transformation. But if we needed to, let me go ahead and make an x and y table. To figure out what values are going to change, all I really need to do is take this x and subtract it to pi over 2. So if I were to subtract 0 by pi over 2, I would be at negative pi over 2, which is further to the left side. All right. But for this one, we didn't really need to make an x and y table. All right, so let's move on to number 2, which is y equals to sine of 2x minus pi over 2. All right, so let's get all of our information for this function. All right, so first off, let's see if we have a phase shift going on. So we see that we have a number that's in the same spot as c, and we actually do have a number in front of x. So I have pi over 2, and I'm going to take that and divide it by 2. So I have pi over 2 divided by 2. So I'm dividing a radian, which is written as a fraction, by a whole number. So what I would do is I would do the keep, change, flip technique. So I keep this first fraction, change the division into a multiplication, and then flip this number. So instead of it being 2, it's going to be 1/2. So I have pi over 2 times 1/2, and that's going to turn into pi over 4. So my phase shift is going to be pi over 4 either to the left or to the right. All right, so now let's figure out the period. Now with the period, I have 2 pi, and we take that and divide it by the coefficient for x, which is 2. So I'm going to divide that by 2, and I end up with pi. All right, so the period for this function would be pi. All right, so now I need to figure out the amplitude. Let me move this up. I'm gonna write it as amp. So for amplitude, it's going to be the coefficient in front of the whole trig function, which there's no number, so my coefficient is 1. So I have 1 unit. So that means that the midline is kind of like the previous, it's like the previous one for the first problem. So I have the midline, which is going to be y equals to 0 since there is no number being added or subtracted to this whole trig function. All right. Now, we see that we have a 2 being multiplied to x, and then it's also being, and then we have minus pi over 2. So we kind of have two transformations happening. So we may need to use the x and y table for this problem. So I'm going to go ahead and make an x and y table. All right, good, you can still see it. So x and then y. All right. So we got to figure out with the number in front of x, meaning the number that's in the same spot as b, what do we do to the x values? So if you guys recall, with the period, if you're given a number for b, that means that we take each x value and divide it by the coefficient for x. So I'm going to take x and divide it by 2. And then after I do that, then I'm going to use the phase shift. So originally we were given a minus, and the opposite of a minus is a plus, and that is a positive direction, which is the right direction. So we have plus pi over 4. Looking at my phase shift, not over here, my phase shift. All right, and luckily the y value doesn't change at all. So I have my original x and y coordinates for sine of x, and we're going to see how the x values change. All right, so I'm going to start off with 0, 0. So I have 0, 0. So I take 0 divided by 2, I still get 0. So I'm going to add, so I have 0 divided by 2, still 0. I add it to pi over 4, that gives me pi over 4. All right. So my first point is pi over 4 or 45 degrees, 0. All right. So moving on. Then I have my next point is pi over 2, 1. So I have pi over 2 divided by 2. So I'm dividing a fraction by a whole number. I do the keep, change, flip. I keep this, I change this into a multiplication, and then I flip this 2 into a 1/2. So it's going to be pi over 2 times 1/2, and that's going to give me pi over 4. And then I add this pi over 4 to pi over 4. And then when I add those two together, I get 2 pi over 4, which simplifies to pi over 2. All right, so I have pi over 2, 1. So pi over 2, 1, still in the same still in the same spot. All right. So moving on, we have pi, 0. So I'm going to take pi divided by 2. That becomes pi over 2. Add that to pi over 4. So I need to make the denominators the same. So I'm going to multiply these two by 2 over 2. So then I get 2 pi over 4. So 2 pi plus pi is 3 pi over 4. So we have 3 pi over 4, 0. All right. So then now we have 3 pi over 2. Divide that by 2. All right, so I'm dividing a fraction by a whole number. So I do the keep, change, flip, keep this, change it to a multiplication, and flip this into 1/2. So that becomes 3 pi over 4. Add that to pi over 4. and I get 4 pi over 4, which turns into a pi. So it's going to be pi comma -1. All right. So then we have, all right. All right, so we're moving on to 2 pi. Oh, let me move this up. So we have 2 pi divided by 2. So I just divide the two numbers. I end up with pi, and then I add it to pi over 4. So I have to make the denominators the same. So I'm going to turn pi to 4 pi over 4. And then I have 4 pi plus pi, which is 5 pi over 4. So I have 5 pi over 4 comma 0. All right. So we have my new graph for sine of 2x minus pi. So I'm going to connect my points. So there we have my x and y. We have my new graph. All right. So if we compare the new graph to the old graph, we see that the horizontal side shrunk a bit, but the height stayed the same. All right. So let's move on to our other graphs. So if we take a look at number 3, we have cosine of x plus 2. We only have one kind of transformation, which is perfect. All right. So if we were to match the plus 2 with the function, we see that plus 2 is in the same spot as d, which is a vertical shift. And not only is it a vertical shift, but it will help us determine the midline, the max line, and the min line. All right. So first off, let's figure out all of our information for cosine of x plus 2. So I have the period. So the period, we have 2 pi divided by the coefficient for x. There is no number in front of x, so it's just 1, and 2 pi divided by 1 is still 2 pi. All right. And luckily we don't have a phase shift, and the amplitude would be the number in front of the whole trig function, which there is none. So my coefficient for the whole trig function is 1, so it's 1 unit. All right, and then we have all of the lines, the midline, the max line, and the min line. So let's go ahead and figure that out. So first I'm going to figure out my midline. All right. So for the midline, it's usually the number that's in the same spot as d, which is positive 2. So my midline is going to be y equals to 2. So all of the original points that were on the x-axis are now going to be on y equals to 2. So my midline is going to be at y equals to 2. So I'm going to draw a dashed line going through the midline. So now I have the max and the min line. So max line, I take my 2 and I add it to the amplitude, which is 1 unit, is 3. So my midline for my max line is 3. And then we have the min line. So for the min line, I take y, well, you really 2, and then I subtract it to 1, I get 1. So all of the points, all the minimum points are going to be at y equals to 1. So all I need to do for number 3 is just move each point 2 units up. So starting over here, I move 2 units up. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. Connect the points. That's really it. All right. Now, you see that the graph, each point just moved 2 units up. And if we take a look, the original maximum points are now at y equals to 3. The minimum point is at y equals to 1. And all of the points that are on the midline are now at y equals to 2. So for this one, we don't really need to make an x and y table. But if we must, let's quickly make an x and y table. All we really need to do is take each y value and add it to 2. All right? So now let's go ahead and continue on with number 4. Now with number 4, we have y equals to 3 times sine of x plus 4. All right, so we have a number in front of the whole trig function, which represents the amplitude, and then we have a plus 4, which is being added to the whole trig function, which is going to be the vertical shift. So let's go ahead and figure out all of my information. So starting with the period. So with the period, we have 2 pi divided by my coefficient for x, which there is no number in front of x, so it's just going to be 1. And 2 pi divided by 1 is still 2 pi. All right, and then we have amplitude. Now the amplitude is a coefficient in front of the whole trig function, which is 3. So my amplitude is 3 units. So from the midline to the max or the min is going to be 3 units. All right, and then we have the max line and the min line. All right. So with the midline, it's going to be y equals to 4, same spot as the number for D. Max line, I take the 4 and I add it to the amplitude, which is 3. And min line, which I take the 4 and subtract it to the amplitude, which is 1. So I have my midline, which is at 4. My max line, which is at 7, because 4 plus 3 is 7. Some of you guys already figured it out, and I didn't even finish. But that's okay. And then we have the min line, which is 1. Okay? So all we really have are changes for the vertical, meaning the height. So if we take a look, we see that we have 0, 0, pi over 2, 1, pi, 3 pi, 0, 3 pi over 2, -1, and 2 pi. So this was a midpoint, a max, mid, minimum, and mid. So what I can do instead of making an x and y table is kind of match the original position to the new position for the new function based on this. So this is a midpoint. So my midline for this is going to be y equals to 4. So my new point is going to be 0, 4. So any points that were on the midline, which was y equals to 0, are now going to be at y equals to 4. Just like for pi, it's going to move up to pi over 4, and 2 pi, which is going to move to 4. All right, so we have all the points for the midline, and then let's take a look at the max. So I only have one max, which is pi over 2. And originally the max for the original graph was 1, but now the new maximum output is 7. So it's going to be pi over 2, 7. And we have 3 pi over 2, -1. And -1 was the original minimum. And my new minimum is +1. All right. Now I'm going to connect my points. So for me, I didn't really need to use an x and y table for number 4, because what I was able to do was figure out the original positions for the original graph, and then use the same position, but now plot it with new output values. But if you guys if you guys were to use an X and Y table, I'm gonna do it below here. Really, the Y values are gonna change, the X values stay the same. So with that, what I would do is, since we have a 3 in front, and whenever we have a number for the amplitude, I multiply that to the Y values, and then I would add it to 4. So what you can do if you want to make an X and Y table is take each Y value, multiply by 3 first, and then add it to 4. All right, so let's move on to 2 more problems. So we have number 5, and all right, so we're gonna move on to the next problem, which is y equals to 2 times sine of 4x minus 3. All right, so if we take a look, we see we have 2, which is in the same spot as the amplitude. 4 is in the same spot as the period, and the minus 3, which is on the same spot as the vertical shift. So we have A, B, D. All right, so let's go ahead and figure out first the amplitude. So we have the amplitude, which is at 2. So amplitude would be 2 units. Then we have the period. Let me see. Move this up. Then we have the period, which I take the coefficient 4x, which is 4x. So I have 2 pi and divided by 4. And then I get pi over 2. So now I have the period. So now I need the vertical shift. All right. So the vertical shift is minus 3. So we're just going to move each point 3 units down. So with that being said, I can go ahead and figure out my mid line, my max line, and my min line. So let's go ahead and figure out the mid line. So with the midline, it would be y equals to negative 3. So we have y equals to negative, we have y equals to negative 3. So now what I'm going to do to figure out the max and the midline, min, is I'm going to take my y, specifically the negative 3, and I'm going to add it to 2, which is the amplitude. So negative 3 plus 2 is negative 1. And then the min, we have y equals to negative 3 minus 2, which is negative 5. So I have all my 3 lines. The min line, which is at negative 3. The max line, which is at negative 1. And the min line, which is at negative 5. So we have those. So we have our 3 lines. But even with that, we also have a change in period. So I am going to be using an X and Y table since we do have 3 transformations happening. All right. So let's go ahead and make an X and Y table. All right, so starting off with 0, 0. So for the x values, I take whatever coefficient is in front of x and divide it. And then for my y values, I multiply whatever the coefficient is for the whole trig function. And then after that, subtract it to 3. So I have x divided by 4. So 0 divided by 4 is still 0. So still have 0. And then I have 2 times 0, which is still 0. And then I subtract it to 3, I get negative 3. So my first point is going to be 0, comma, negative 3. So then we're moving on to the next point, which is pi over 2, comma, 1. So pi over 2, I divided by 4. So I have a fraction divided by a whole number. I do the keep, change, flip. Pi over 2 divided by pi over 2 stays the same. I change the division to a multiplication, and then I flip this 4 into 1/4, and that's going to become pi over 2 times 1/4. So that becomes pi over 8. All right, so I have pi over 8, and if we convert that into radians, we actually get 22.5. So pi over 8 is somewhere in between 0 to pi over 4, which is a 45 degrees. All right, so now let's figure out my new y value. So for my y value, I have 1 times 2, which is 2. Subtracted to 3, I get -1. All right, so moving on to the next. So I have pi over 8, which is in between 0 to pi over 4. So I'm just going to put it right here. So then I have pi over 2 divided by 4. Pi over 2. My apologies, it's pi, not pi over 2. All right, so I have pi instead of pi over 2 as the next one because we already did pi over 2. So we have pi divided by 4. So that's just going to turn into pi over 4. All right, so we have pi comma 0. So I do 0 times 2. I still get 0. So I'm going to subtract it to 3. I get -3. So I have pi over 4 comma -3. So usually it should be over here. All right. So now the next one is 3 pi over 2 divided by 4. And I keep this, change it to a multiplication, and then flip this fraction. It becomes 3 pi over 8. And if we were to convert that into degrees, so let me write it 3 pi over 8. Convert. I get 67.5. So it's going to be in between pi over 4 to pi over 2. So let's say right here. And then we have the fifth point, which is 2 pi divided by 4. So I can write this as 2 pi over 4, which will simplify as pi over 2. Oh, I didn't even do the y value. Oops. All right, so since 3 pi over 2 had a minimum point, which was -1, my new minimum is going to be at -5. But if I were to do the arithmetic, I have 2 times -1 would be -2 minus 3. I get -5. All right. So then I have 2 pi. So I already have 2 pi divided by 4 is pi over 2. So now I have 0 times 2, which is still 0. Subtracted to 3, I get -3. So I have pi over 2 comma -3. I'm going to connect my points. Should have done it over here. All right. So this is going to be my graph for 2 times sine of 4x minus 3. So if we take a look, we see that comparing from the original to the new graph, it shrunk horizontally, it compressed, and the height increased. We kind of stretched the graph out. All right, so now we have one more problem, which is number 6. We have 2 times cosine of x minus pi over 2 plus 3. So we have 3 transformations going on. So I'm going to write it up here. So first off, let's start off with the amplitude. So with the amplitude, I have 2 in the front, it's still 2 units. All right, then I have the period. With the period, it would be 2 pi divided by a number in front of x, which there is no number in front of x, so it's gonna stay as 2 pi. And then we actually do have a phase shift. So we have pi over 2, and we take the pi over 2 and we would divide it by the coefficient for x, but there is no coefficient. So it's my phase shift is pi over 2. And if we were to follow the rule for phase shift, we follow the opposite sign of what we're given. So the sign was minus, and the opposite of minus is a plus. So that means that if we're going to a positive direction horizontally, we're going to the right direction. So we have pi over 2 to the right. So now we can take a look at this plus 3, which would be my midline. And then I have my max and my min line. So to figure out the max line, I'm going to take 3 and add it to 2, and I get 5. For my min line, I take 3 and subtract it to 2, and I get 1. So I have all of these pieces of information. So let me go ahead and put all the lines. The midline, max line, and min line. So I have I'll have all of these 3 lines. So now I can go ahead and try to graph my new function. Fortunately, we ran out of space. So what I'm going to do is I'm going to take a sticky note and I'm going to put it over here. Let's say over here. Okay. So I'm gonna make my X and Y table. So starting off with 0, 1. So all right, so if you take a look, we have 2, pi over 2, and 3. So the pi over 2 is a phase shift, a horizontal shift, so that affects X. So we said it would follow to the right direction. So we're going to take each X value and add it to pi over 2. All right. And then for the Y values, I have a coefficient in front of the whole trig function. So I'm going to multiply 2 to Y. And then after that, I add it to 3. All right. So let's start off with 0, 1. So I take 0 and I add to pi over 2. And I get pi over 2. And then I have 1 times 2, which becomes a 2. And then add it to 3, which gives me a 5. So I have pi over 2, comma 5. All right, next problem. Next point, to be exact. Not problem. We didn't even finish this one. So now we have pi over 2. Add that to pi over 2. I get 2 pi over 2, which becomes a pi. All right, so for the horizontal shift, we're just moving pi over 2 or 90 degrees. And then I have, what's it called? I have 0 times 2, which is still 0, added to 3, I get 3. So I have pi, comma 3. All right, then I have 3 pi, comma 2. Comma 2, 3 pi over 2, comma, or actually, I actually skipped the pi instead of to 3 pi over 2. So let me go ahead and write pi. Let me not skip. So I have pi plus pi over 2. I turn it into a fraction with the common denominator. I turn it to 2 pi over 2. So 2 pi over 2 plus pi over 2 gives me 3 pi over 2. All right, and then originally the Y value was -1. Multiply that to 2, I get -2. Add that to 3, I get +1. So now I'm at 3 pi over 2, comma 1. All right, so now I'm moving on to, let me go ahead and get another sticky note because I'm running out of space. All right, so now I got 3 pi over 2 plus 2 pi, plus pi over 2. I get 4 pi over 2, which simplifies to 2 pi. All right, so then we had 0 for the original Y value, multiply that to 2, I still get 0. I add it to 3, it is now becomes a 3. So 2 pi, comma 3. And then if we were to take a look at 2 pi, It went above the cork board. All right, so we have 2 pi plus pi over 2. So I need to turn this, I need to have the common denominator. So I'm going to turn 2 pi into 4 pi over 2. So 4 pi plus pi is 5 pi over 2. Then I have, originally it was 1. So you have 1 times 2, which gives me 2 plus 3, and that gives me 5. All right. So the pattern will start to repeat at 5 pi over 2. All right. So we have my graph for 2 times cosine of x minus pi over 2 plus 3. Why do you show that? Okay, now we have it. 2 times cosine of x minus pi over 2 plus 3. So with the examples that I presented, we were able to see which problems we didn't really need an x and y table for, and which problems were necessary. It's up to you guys to see if you want to make an x and y table based on the amount of transformations that we have. If you guys still have any questions, feel free to email me. Have a wonderful day, you guys.